Assalamu alaikum everyone. I am Osama Arif and today I will be presenting a statistical dive into computer science and data science students. This analysis conducted by me and my teammate Halima compares the performance trend of students admitted to Air University in fall 2024. So here's an outline of our presentation. First of all, we will discuss the frequency distribution of score for both computer science and data science students. Then we will explore descriptive statistics, visualizations like histogram, density plots, and pie chart. Afterward, we will explore skewness, cortices, and a comparative analysis, including violin plots. Finally, we will conclude with key takeaways from the analysis. Frequency distribution of computer science students. This table highlights the frequency distribution of aggregate merit scores for computer science student, and as you can see, the most common score range is between 58 and 68, which has the largest number of students, and that is 1752. On the other hand, if we talk about data science students, according to the frequency distribution table, data science students mostly scored in the mid-range between 50 and 59, and fewer students achieved scores in the upper range. This suggests that these scores are more tightly clustered around the middle. Descriptive statistics. Now let's compare some key descriptive statistics. The mean of CS is 64.29, which is slightly higher than the mean of data science students. And if we talk about median and mode, both groups have approximately similar median and modes. However, computer science students shows a wider range, variance, and standard deviation, indicating more diverse score compared to data science students. Histogram. This histogram represents the scores of computer science and data science students on x-axis with their corresponding frequencies on y-axis. In sites, this histogram visually compares the score distribution, so both groups are centered around the 50 to 70 range, indicating a similar overall trend. However, computer science scores appear more spread out as compared to data science scores. Density plot. This density plot gives us a smooth comparison of the score distribution for computer science and data science student. For computer science student, the curve is wider and flatter, which indicate a greater variability in their scores. For DS students, the curve is narrow and taller, which shows that their scores are more tightly clustered around the mean. So we observe that CS students have more diverse score, while data science students shows more consistent performance. Pie chart. These pie charts break down the score ranges for CS and DS students, giving us a clear picture of how the scores are distributed. For CS student, the largest group scored between 58 and 68, comprising 34.9% of the total population, and for DS, 32.8% scored between 50 and 59. Skewness and cortices. Skewness. The skewness of computer science is 0.13 and 0.17 is for data science. Both are greater than 0, so it's mean both are slightly right skewed, meaning most score are below the mean but a few higher score pull the tail to the right. Cortices. The value of cortices for computer science is minus 0.73 and for data science is minus 0.62. As they both are less than 3, so these are plateautic distribution, which indicate flatter peak compared to normal distribution. Comparative analysis. Our comparative analysis highlights some important findings. First, the t-statistic of minus 0.11 and a p-value of 0.92 strongly suggest that there is no significant difference between the mean score of CS and DS student. However, CS students have more variability in their score, which means their performance is more diverse. On the other hand, DS students show tighter score distribution, which indicate more consistent performance. Violin plot. Then we use violin plot to confirm our previous trend, and it shows no difference in the score distribution between the two groups. So, in conclusion, our analysis revealed that while both computer science and data science students have similar averages and distribution, but data science students shows greater consistency and overall better performance. On the other hand, computer science students have a broader range of scores, particularly in the lower and upper extreme, which shows greater variability. This is our Python notebook. First of all, we have imported all the required Python libraries that we're gonna use. Then we made a frequency distribution table having column of class, frequency, class boundary, midpoint, and cumulative frequency. Then we did descriptive statistics in which we find mean, median, mode, standard deviation, etc. Afterward, we did data visualization in which we plot histogram, pie chart, box plot, density plot, etc. Afterward, we find probability insight and percentile ranking. And for CS, we did the same thing as we did for data science. First of all, frequency distribution table having same column, and then we find descriptive statistics. Afterward, data visualization. For comparison, first of all, we use pandas function pd.describe to compare both groups. Then we plot density plot graph. Afterward, we perform t-test. Then histogram for comparing their merit scores. Afterward, we plot violin plot. And in last, we plot a histogram for comparing their distribution.